We all think about speed limits on the highway, but the universe has them too. The big one, of course, is the speed of light.
Right, the absolute limit.
But there's another, more subtle speed limit. It's how fast our solar system is supposed to be moving through the cosmos, relative to the background glow of the Big Bang.
The cosmic rest frame, yeah.
And new research out of Bielefeld University is suggesting we are just blowing past that limit. It's a finding that could really throw a wrench into the standard model of cosmology.
It really could.
Okay, so that's our mission for this deep dive. Let's unpack this. What exactly did they find, and why does it matter so much?
Well, the headline finding is pretty dramatic. The measurement shows our solar system is moving more than 3 times faster than our best models predict.
3 times? That's not a small error.
Not at all. To put a number on it, the source count dipole, that's the signal they measured, exceeds the expected value by a factor of 3.67.
Wow.
And this isn't a maybe. It's a 5.4 sigma discrepancy. In particle physics, 5 sigma is the gold standard for a discovery.
Okay, but measuring our speed against the entire universe? I mean, that sounds impossibly complex. How do you even do that?
It is incredibly challenging. You can't use visible light, for instance. There's just too much dust and gas in the way.
So what do you use instead?
You use radio waves. The team focused on distant radio galaxies. Their emissions can punch right through all that cosmic dust. They used the LOFAR telescope network across Europe, combined with a couple of other really robust data sets.
And what's the actual signal they're looking for? What tells them we're moving?
They're essentially looking for a subtle headwind effect.
A headwind. So we see more galaxies in the direction we're headed.
Exactly. They call it a dipole difference. A few more galaxies pop into view in our direction of travel, and a few less behind us. That tiny difference tells you your velocity.
But I imagine the data is incredibly messy.
Oh, it's very messy. You have sources that look like one galaxy, but are actually several. The team had to use a really sophisticated statistical method just to filter out that noise. But even after all that, the result was clear. The speed discrepancy, that huge 5.4 sigma signal, was still there.
It's amazing what you can pull out of complex data if you have the right tools.
It really is.
And speaking of dealing with complex data and finding the right signal, we want to give a quick shout out to our sponsor, Embersilk.
Absolutely.
If you're trying to figure out where AI agents could make the most impact for your business or even your personal life, they're the ones to talk to. For AI training, automation, software development.
Anything AI, really.
Check them out at embersilk.com. That's EMBERSILK.com.
So getting back to it, this finding creates a profound conflict.
A conflict with what, Isa?
With the very foundation of modern cosmology, an idea called the cosmological principle.
Right. That's the assumption that on the grandest scales, the universe is basically the same everywhere.
Uniform. Precisely. Homogeneous and isotropic. And our expected speed, that cosmic speed limit, is calculated based on that assumption of uniformity.
But this measurement is saying something is not uniform.
Mm-hmm.
That factor of 3.7, what does that imply?
It suggests the matter distribution is far lumpier than we thought. That dipole difference is way too big. It means the headwind is more like a gale force wind. Either the universe isn't as uniform as we assumed, or our motion itself is creating this effect because we're moving so fast.
And this isn't the first time we've seen hints of this, is it? I feel like other studies have pointed to something similar.
You're absolutely right, and that's what makes this so compelling. Previous research using quasars measured in the infrared spectrum found a very similar discrepancy.
So different instruments, different wavelengths, but the same weird result.
Exactly. That tells us this is probably a real feature of the universe, not just some fluke in the data.
So where does that leave us? What are the big possibilities here?
Look, it really boils down to 2 things. One, our ideas about the large-scale structure of the universe are just wrong.
Right.
It's not as smooth as the cosmological principle demands.
And a second.
The second is that maybe the distribution of these radio galaxies themselves is not as uniform as we believe, and that's what's skewing the measurement. But either way, the standard model is under some serious pressure.
This is a real game changer. And with huge new surveys like the Square Kilometre Array coming online soon, we're going to get even better data.
We are. This question will likely be settled one way or another.
And if this discrepancy holds up, we might have to fundamentally re-examine the cosmological principle itself. The idea that the universe looks the same in all directions might just be wrong.
And that would change everything.
Just an incredible thought to end on. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.